So today we'll be starting with the chapter combustion and flame. Now what is combustion? So combustion in simple words, if we can talk, it's burning. Burning of anything, like burning of paper, burning of any fuel. Okay. Now if we'll talk about the definition, so combustion is a chemical process. Chemical process means it will completely change. A chemical reaction or a chemical process is a process which cannot be reversed. And here a substance always reacts with oxygen of air. So for a thing to burn, for anything to burn, there should be air, there should be oxygen because it is a supporter of combustion. Okay. And in this process some heat and light is always released. Okay. So now let's start with the chapter. We use different kinds of fuel for various purposes at home. Like at home, if we'll talk about wood, coal, okay, for making food purposes, then in industry, and for running automobiles. For automobiles, if we'll talk, so we'll talk about CNG, petrol, diesel, okay. So in industry also coal can be used, then natural gas can be used, then petroleum products like diesel, fuel oil, etc. can be used. Okay. Now they are asking you, can you name a few fuels used in a home? So that I have already answered wood, coal. Then name a few fuels used in trade and industry. Then that will be coal, petroleum products like diesel, fuel oil, etc. Then what fuels are used for running automobiles? It's CNG, diesel, petrol. Okay. Your list will contain fuels like cow dung, wood, coal, charcoal, petrol, diesel, compressed natural gas, etc. So wood, coal, charcoal, if you will talk about, that can be used as a fuel in homes. Then coal can also be used as a fuel in industries. Then petrol, diesel, and CNG can be used as a fuel in automobiles. Okay. Now you are familiar with the burning of a candle. Whenever you burn a candle, you can see those wax melting and the vapors going out, right? Now what is the difference between the burning of a candle and the burning of a fuel like coal? Maybe you will be able to guess right that candle burns with a flame. Whenever you light a matchstick and burn a candle, you will see a flame, right? Whereas the coal does not. Coal does not burn with a flame, right? Similarly, you will find any other materials burning without a flame. Now let us study the chemical process of burning and types of flame produced during this process. Okay. Now what is combustion? So I have already told you what is combustion. So combustion is a chemical process in which a substance reacts with oxygen to give off heat. Okay, to give off heat is called combustion. The substance that undergoes combustion is said to be combustible. Any substance which you are burning is said to be a combustible substance. It is also called a fuel. So it is also called a fuel because these are the materials that will react with oxygen of air to release some heat and light energy. Okay. That is why they are called as fuel. Now fuel may be solid, liquid or gas. Sometimes light is also given off during combustion either as a flame or as a glow. Now why they are saying as a glow? Because if you remember last year in 7th class we have done a activity on magnesium ribbon. So when you heat that magnesium ribbon with a pair of tongs on the Bunsen burner, what happened? It burned with a brilliant white flame, right? And there also it was written as it was not a flame. It was actually a glow. Okay, it burns with a brilliant white glow, right? So now let's come here to this paragraph first. Recall the activity of burning of magnesium ribbon performed in class 7. We have already discussed this. So we learned that magnesium burns to form magnesium oxide and produces heat and light. We can perform a similar activity with a piece of charcoal. So hold the piece of charcoal with a pair of tongs and bring it near to a flame or a candle or a Bunsen burner. So we will observe that charcoal burns in air, and we also know that coal too burns in air, producing carbon dioxide, heat and light. Now both charcoal and coal, they do not produce a flame, they always produce a glow. Okay. Similarly, magnesium ribbon also produce glow, right? Now, in the reactions mentioned above, magnesium and charcoal are combustible substances. Now, because we have burned both of these things, so these are combustible substances. Now, Bhujo is asking, we were told that food is a fuel for a body. Now, why food is fuel for a body? So, because it provides us the energy needed for all the body functions, right, for digestion, and it also serves as a fuel. Why? Because the body breaks down nutrients like carbohydrates, fats, proteins to release energy in the form of calories, which are then used for breathing, for the circulation and for doing physical activity and for the growth of our body. So that is why food is also a fuel, because it's burning. The food is burning inside the body and it is giving us some useful components. Okay, this answers the question. Now the next page. So Paheli says rightly so, because in our body food is broken down with reaction with oxygen and heat is produced, and also heat is produced because we have studied that in the process of combustion some heat and light is produced. So by burning of food, obviously light will not be produced, but yes, heat will be produced. Now let's see this activity 4.1. Collect some materials like straw, matchstick, kerosene oil, paper, iron nails, stone pieces, glass, etc. And under the supervision of a teacher, try to burn each of these materials one by one. If combustion takes place, mark the material combustible, otherwise mark it non-combustible. So let's see. So see, wood will be combustible, yes. Paper will be combustible. Iron nails will be non-combustible. Then kerosene oil will be combustible. Stone piece non-combustible. Straw is dry grass, so combustible. Charcoal again combustible. Matchstick again combustible, and glass is non-combustible. So three items, iron nail, stone and glass, are non-combustible and rest are combustible materials because we can burn on these. Okay. Now can you name some more substances which are combustible? This you can do yourself. Now let us investigate conditions under which combustion takes place. Now you will be better able to understand how oxygen is a supporter of combustion and how combustion takes place. So see this activity. This is the activity. Now these are three candles. They are saying fix a lighted candle on the table, put a glass chimney over the candle and rest it on a few wooden blocks in such a way that air can enter the chimney. Okay, air can enter the chimney in 4.2a. You can see here air can enter because wooden blocks are kept under it. Observe what happens to the flame. Now they are saying now remove the blocks and let the chimney rest on the table. Okay, see now what happens here in A, when the wooden blocks are kept beneath it, so the air was able to enter inside it. Okay, and we all know that air is needed, very much needed for the combustion or for the candle to keep on burning. So because air was entering from down, so the flame was burning steadily and unaffected because there was supply of fresh air. Okay, so that is why you can see the flame is burning. Now in the other one they have removed these wooden blocks and now whole candle is covered properly. Now because whole candle is covered properly, the flame will get extinguished because there is no supply of fresh air inside it, no supply of oxygen inside it. That is why you can say that there is no flame now. The candle is extinguished. Now in the third one, they have kept a plate over the glass. Now still, because they have covered it with a glass plate or with a plate, the candle is not getting any supply of fresh air, that is why it gets extinguished. Okay, now from this activity we can conclude that the candle burns freely in case A, right, when air can enter the chimney from below. Then in case B, when air does not enter the chimney from below, the flame flickers and produces smoke. In case C, the flame finally goes off because the air is not available. Now because the air is not available, so the flame goes off. Here, if we will talk about case B, so candle was burning for like 4 to 5 seconds and then it got extinguished because till 4 to 5 seconds in some time there was supply of oxygen inside the glass, but after that time the supply went off and that is why the flame flickered and it produced smoke. Okay, so here now from this activity we conclude that air or oxygen of air is very important for a candle to keep on burning. Okay, it requires a continuous supply of oxygen, a component of air for a fuel or this wax to react and produce heat and light. Okay, when oxygen was restricted, the flame became unstable, it flickered and incomplete combustion like smoke, leading to extinguishment in third one. In C part, leading to the extinguishment of candle. Okay, because the oxygen completely ran out. Now Bhujo says, we have read that sun produces its own heat and light. It is also some kind of combustion. Now the answer is in the sun, heat and light are produced by nuclear reactions. Okay. Now activity 4.3. Place a piece of burning wood or charcoal on an iron plate or tawa. Cover it with a glass jar or a tumbler or a transparent plastic jar. Observe what happens. Does charcoal stop burning after some time? Can you think of a reason why it stopped burning? The same case of candle. The charcoal will stop burning after some time because now by covering it with a glass jar, there is no fresh supply of oxygen inside it. And for the charcoal to keep on burning, it requires oxygen, right? So that is why the charcoal stopped burning after some time. Okay. Now you might heard that when the clothes of a person catch fire, the person is covered with a blanket to extinguish fire. Can you guess why? Because whenever we cover the person whose clothes have caught fire by caught fire, so whenever we cover that person with a blanket, what happened? The blanket will create a cover, okay, and it will stop the supply of oxygen. And when there will be no supply of oxygen, the fire will not keep on burning and it will get extinguished. Okay, the blanket acts as a cutoff of oxygen, the cutoff of air, right? Now recall some of your experiences. Does a matchstick burn by itself? How does it burn? Now how a matchstick burns? Now we will be talking about a completely new topic here, ignition temperature. Then I will explain you this matchstick answer. Okay, now let's first know what ignition temperature is. So the ignition temperature is the lowest temperature at which a substance catches fire is called ignition temperature. Okay, so this is the definition of ignition temperature. Now let's answer this question. That does a matchstick burn by itself? So the obvious answer is no. A matchstick doesn't burn by itself at room temperature. Now as we will proceed with the chapter, we will see that some things like white phosphorus, it burns itself at room temperature, okay, because the ignition temperature is very low. Now the matchstick ignition temperature is not that low, so it does not burn by itself at room temperature. It need to be burned. So whenever we will strike a matchstick against a rough surface provided on the side of the matchbox, it will generate friction, and because of that heat will be generated, and it will the head of the matchstick will light. Okay, that is how the matchstick burns. Then you must have had an experience of burning a piece of paper. Everyone has done that. Does it burn when a burning matchstick is brought near it? Yes. Because the ignition temperature of paper is very less, that is why it burns quickly when a burning matchstick is brought near it. Now, can you burn a piece of wood by bringing a lighted matchstick near it? No. Because the ignition temperature of wood is much more than that of paper. So it is not easy to light a log of wood, a piece of wood with a lightning matchstick. That is not easy to light a wood, to burn a piece of wood. Okay. Now before proceeding, okay, let's do this one again, and then I will tell you the forest fire paragraph. Why do you have to use paper or kerosene oil to start fire in wood or coal? Now why you have to, I've already told you can't burn a piece of wood with a lighted matchstick, so we need something else like paper or kerosene oil to start fire in wood or coal. Because the temperature of paper and kerosene oil is, the ignition temperature of paper and kerosene oil is much less. So because they have low ignition temperature means they will catch fire easily. That is why they will produce enough initial heat, okay, enough starting heat to burn that piece of wood, okay. And once that piece of wood also gets heated by the initial heating of that paper and kerosene oil, you will be able to start fire in wood or coal, okay. So wood and coal, they need significant heat to start burning, okay, which a matchstick alone cannot provide, right? Now have you heard of forest fires? Now see here this paragraph. During extreme heat or summer, at some places dry grass catches fire. From the grass it spread to trees, and very soon the whole forest is on fire. It is very difficult to control such fires, okay. So you can learn this box, okay, just learn it, this is important. Then do these experiences tell you that different substances catch fire at different temperatures? Yes. So we have already discussed that different substances catch fire at different temperatures. So the lowest temperature at which a substance catches fire is called as ignition temperature. You can also learn this definition. Now, can you tell now why a matchstick does not catch fire on its own at room temperature? I've already answered the question. I've already answered this question. Then why does the matchstick start burning on rubbing it on the side of the matchstick? Because of the friction created. When we rub the matchstick, the friction gets created, and because of that, enough heat will be generated, and the head of the light stick gets lit. Okay. Now let's read the history of matchstick. The history of the matchstick is very old. More than 5,000 years ago, many small pieces of pine wood dipped in sulfur were used as matches in ancient Egypt. The modern safety match was developed only about 200 years ago. A mixture of antimony trisulfide, potassium chlorate, and white phosphorus with some glue and starch was applied on the head of a match made of suitable wood. When struck against a rough surface, white phosphorus got ignited due to heat of friction. This started the combustion of the match. However, white phosphorus proved to be dangerous both for the workers involved in the manufacturing of matches and for the users. These days, the head of the safety match contains only antimony trisulfide and potassium chlorate. So they have eliminated white phosphorus because it was toxic. So now the rubbing surface has powdered glass and the little red phosphorus, which is much less dangerous. But when you will struck the match against the rubbing surface, some red phosphorus gets converted into white phosphorus. This immediately reacts with potassium chlorate in the matchstick head to produce enough heat to ignite antimony trisulfide and start the combustion. Okay. So this is the history of matchstick. Now we find that a combustible substance cannot catch fire or burn as long as its temperature is lower than its ignition temperature. Now for any substance to burn, its temperature should be lower than the ignition temperature. Have you ever seen cooking oil catching fire when a frying pan is kept for a long on a burning stove? Yes. It catches fire, the cooking oil catches fire when a frying pan is kept for a long on burning stove because for a long, till that long time, it has reached its ignition temperature. Now, because it is heated up to its ignition temperature, so it tends to catch fire. Okay. Now, kerosene oil and wood do not catch fire at the room temperature because their ignition temperature is not that low. But if kerosene oil is heated a little, it will catch fire, right? But if the wood is heated a little, it will not catch fire. Does it mean that ignition temperature of kerosene oil is lower than that of wood? Yes. The answer to this question is yes. As compared to wood, the ignition temperature of kerosene oil is much less. So if it will catch fire easily with much less fire. Now, does it mean that we need to take special care in storing kerosene oil? Yes, we should take very special care in storing kerosene oil because it will burn, it will light by very little heat. Okay, the following activity shows that it is essential for a substance to reach its ignition temperature to burn. Now, let's see the activity. Activity 4.4. Now, these are two paper cups. By folding a sheet of paper, they have made this. So, in one paper cup is empty. The second one, if you can see, one paper cup is empty, and this one they are filled with water inside it. Now they are saying heat both the cups separately with a candle. What do you observe? What happens to the empty paper cup? What happens to the paper cup with water? Does water in this paper cup become hot? Now see, the empty paper cup will, when we will place the empty cup over the gas burner, over the flame, it will immediately catch fire because paper has a low ignition temperature, and by just burning a little it will start burning. But the other paper cup which has water inside it, okay, if we will continue heating the cup, we can even boil water in the paper cup. Now the other paper cup which has water inside it, it will not catch fire because all the heat will be transferred to that water inside it and the paper will remain unburnt, right? The paper will remain unburnt, and the inside with the low heat, the paper will not burn. It will get heated, and then if you will increase the heat, the water inside will start boiling, but the paper will not catch fire. Okay. Now the heat supplied to the paper cup. What happened? The heat which was supplied to the paper cup by the candle put beneath it, it was transferred to water by conduction. So here the conduction process was happening. So in the presence of water, the ignition temperature of paper is not reached. because the water was there inside it, so the ignition temperature of paper to burn did not reach. Hence, it does not burn. The other paper cup ignition temperature reached quickly by burning because there was no water inside it. Okay. Now the substances which have very low ignition temperature and can easily catch fire with a flame are called inflammable substances. Okay. Examples will be petrol, alcohol, liquefied petroleum gas, LPG, etc. So these are the inflammable substances which can easily catch fire. Okay. Now these substances, they easily catch fire, burn easily because they have very low ignition temperatures. Okay. And they can also ignite and catch fire at relatively low temperatures, right? So we should safely store them. And if you want a list of some more inflammable substances, so you can add CNG, you can add, then you can add kerosene oil, then you can add zinc powder, then propane, butane, acetone, etc. Right? Now the next topic. So here earlier we discussed about the things which we can burn. Now we are discussing how do we control fire. Now how fire can be controlled. You must have seen or heard of fire breaking out in homes, shops and factories. If you have seen such an accident, write a short description in your notebook. Also share the experience with the classmates. Now find out the telephone number of the fire service in your area. If a fire breaks out in your house or in your neighborhood, just first thing is to do is to call the fire service. Okay. Now Paheli is saying it is very important that all of us know the telephone numbers of the fire service of your area, right? Now, does a city town have a fire brigade station? Yes, it will obviously have. Then when a fire brigade arrives, what does it do? So what does it do? It pours water on the fire. What happens by pouring that thick stream of water on the fire? Water cools the combustible material, the burning material, so that its temperature is brought below its ignition temperature. Now, why the fire got started? Because the temperature reached to the ignition temperature. Now, water cools down that temperature and it brings the temperature to below its ignition temperature, and this prevents the fire from spreading. Then water vapors, and when the fire is extinguished with the reaction of water, there are water vapors. Now water vapors, they surround the whole area like a blanket. Okay. And that will cut the supply of oxygen and the fire will also get extinguished. Okay. So water vapors surround the combustible material, helps in cutting off the supply of air, so the fire is extinguished. Okay. So you have learned that there are three essential requirements for producing fire. Can you list these requirements? Okay. So when we was discussing about the combustion, so the three factors were very important for a substance to burn. First was fuel, a combustible material, then air, supply of oxygen, then heat. Heat to raise the temperature of the fuel beyond its ignition temperature. You have to heat the substance beyond its ignition temperature. That is, then only it will burn. Okay, so these three factors are very necessary. Now, fire can be controlled by removing one or more of these requirements. Now, if you will completely eliminate the combustible substance of fuel, or there is no air, oxygen, then the fire will never occur. Okay, so fire can be controlled by removing one or more of these factors. The job of a fire extinguisher is to cut off the supply of air or to bring down the temperature of the fuel or both. Now, a fire can be extinguished by either cutting off the supply of air or by bringing down the temperature of the fuel so that it will cool down and then the fire will get extinguished. The temperature will come below its ignition temperature. Now, notice that the fuel in most cases cannot be eliminated. If, for instance, a building catches fire, the whole building, if a building has caught fire, the whole building is a fuel in this case. Okay. Now let's see how we can extinguish fires. This box is also very important, children. So please listen it very carefully and learn it. The most common fire extinguisher is water. Most common. But water works only when things like wood and paper are on fire. So you can only extinguish fire, wood or paper using water. If electrical equipment is on fire, water may conduct electricity and harm those two trying to douse the fire. If an electrical equipment is on fire, then water may conduct that electricity and harm those trying to douse the fire. So it is not suitable to douse the fire using if the fire is on any electrical equipment using water. Water is also not suitable for fires involving oil and petrol. Why? Because oil is lighter than water. So what will happen? Oil will float on the water and water will sink below. And what will happen? The water will sink below and on the top the oil will keep on burning. So this is not advisable to extinguish a fire for relating to oil and petrol with water, because you will not be able to extinguish it. Now, for fires involving electrical equipment, if the electrical equipment is on fire or any inflammable material like petrol is on fire, so then the best fire extinguisher is carbon dioxide, CO2. Okay, because CO2 being heavier than oxygen, it covers the fire like a blanket. Okay, now since the contact between the fuel and oxygen is cut off, the fire is controlled. The added advantage of carbon dioxide or CO2 is that in most cases it does not harm the electrical equipments. Then how do we get the supply of this carbon dioxide? Now where we will get this carbon dioxide from? So it can be stored at high pressure as a liquid in cylinders. Then in what form is the LPG stored in cylinders? Again in the liquid form, which you use at your in liquid form in the cylinders it's filled, okay, but you use it as a gas, okay, in your stoves, in your kitchen stoves. When released from the cylinder, CO2 expands enormously in volume and cools down. So it not only forms a blanket around the fire, it also brings down the temperature of the fuel. Okay. So it does not only act as a blanket to cut off the supply of the air, it also brings down the temperature of the fuel. That is why it is an excellent fire extinguisher. Another way to get CO2 is to release a lot of dry powder. If you do not have a cylinder, right, obviously, then you can immediately, arrange for some dry powder of chemicals like sodium bicarbonate, which is baking soda, or potassium bicarbonate, okay? Near the fire, these chemicals give off CO2. When you will sprinkle this dry powder around the fire, it will give CO2 and the fire gets extinguished, okay? Now let's see the next topic, types of combustion. Okay. Now there are three types of combustion: rapid combustion, spontaneous combustion, and explosion. Okay, explosive combustion. Now they say bring a burning matchstick or a gas lighter near a gas stove in the kitchen. Turn on the knob of the gas stove. What do you observe? Now what do you observe? That you will be able to light the gas stove by just simply burning a matchstick or a gas lighter. Okay. So what is this? This is a rapid combustion. This is a reaction with rapid combustion, because in this you will find that gas burns rapidly and produces heat and light. Okay. Such combustion is known as rapid combustion. Okay. So in rapid combustion, a substance burns and a large amount of heat and light are produced in a short time. Okay. This is a rapid combustion. Then if we will talk about spontaneous combustion, so spontaneous combustion is a reaction which occurs on its own, okay, without the help of any matchstick or any gas lighter. It will start burning on its own. So there are substances like phosphorus which burn in air at a room temperature because it has a relatively low ignition temperature. So the type of combustion in which a material suddenly bursts into flames without the application of any apparent cause is called spontaneous combustion. Okay, so without the help of any external heat or without any factor which causes heat, it suddenly occurs without the application of any apparent cause. So there is no cause behind that combustion. See here, eh, just this box is also very important. Learn it. Spontaneous combustion of coal dust has resulted in many disastrous fires in coal mines. So coal dust also is a reaction example of spontaneous combustion. Then spontaneous forest fires are sometimes due to heat of the sun or due to lightning strike. So that the dry grass there or the grass which is spread, the leaves which are spread on the ground in the forest, they get heated to the ignition temperature because of the heat of the sun and they get fire. Okay, they easily catches fire. However, most forest fires are due to the carelessness of human beings. It is important to remember that the campfires must be completely extinguished before leaving a forest after a picnic or a visit. Okay, so we should take care of these factors. Now, we generally have fireworks on festival days, on Diwali days, right? When a cracker is ignited, a sudden reaction takes place with the evolution of heat, light, and sound. So, a large amount of gas formed in the reaction is liberated. Such a reaction is called explosion. Okay. Now, when you burst a cracker, what happens? The chemicals inside the cracker they get that heat, they start burning, and then they produce heat, light, and a sound. So, in explosive combustion and explosion, a sound is also produced along with heat and light. Explosion can also take place if pressure is applied on the cracker. If you hit the cracker hit hard, okay, hit the cracker hard, then also this explosion can occur. So we should avoid doing such things. Now the next topic, flame. So what is the flame? So flame is that part of the fire, that gaseous part of the fire where combustion is taking place and it produces heat and light. And flame is also a visible reaction. Okay, we can easily see that. You can easily see that flame coming from a combustible substance, right? And these are only produced by the combustible substances such as candle, kerosene, oil. Okay, but charcoal and coal, they do not produce flames, right? Because they do not glow, they do not vaporize on burning. The substances which vaporize on burning only they produce a flame, and the substances which do not vaporize on burning, like coal and charcoal, they do not produce flames. Okay, so if we'll see this, observe an LPG flame. Can you tell the color of the flame? So the color of the LPG flame, if you can see in your at your homes, in your gas stove, you will see it's blue in color, right? And when you see the color of a candle flame, it is yellow in color. Okay, and why these colors differ? This I will explain you. Okay. So let's see here. Recall your experience of burning a magnesium ribbon in class 7. If you do not have experience of burning the remaining items, you can do that now. So you can always do this with the help of an adult, right? Under the supervision of some adult member. So if you remember about magnesium ribbon, when we burn it, it doesn't produce flame. Okay, it doesn't produce flame. It only produces a glow, a brilliant white light. Okay. Now let's see this. We have 5 items and we have to tell which will form flame and which will not form a flame. Okay. So candle, yes, definitely it will form a flame. Magnesium will form a flame. Camphor will form a flame. Kerosene stove, okay, then it will also form a flame, but charcoal does not form flame. Okay. Now let's see here. See this figure 4.8. Colors of a candle flame and the flame of a kitchen stove. See, kitchen stove you can see this is blue in color and this is yellow in color. Okay. And why this is blue and why this is yellow, I will tell you with the structure of candle. Okay. Further. And see here, these are 3 different types of burners: kerosene lamp, a candle, and a Bunsen burner. And you can also see the colors of the flame. You can differentiate red clearly, yellow clearly, then blue clearly, right? Now record your observations and mention whether on burning the material forms a flame or not. So this we have already done this table 4.2. Now structure of a flame. So now they are saying light a candle, hold a 4 to 5 centimeter long thin glass tube with a pair of tongs and introduce its one end in the dark zone of a non-flickering candle flame. See here, as it's done here. Now bring a lighted matchstick near the other end of the glass tube. Do you see a flame caught at this end of the glass tube after a while? If so, what is that produces a flame? Notice the wax near the heated wick melts clearly. Okay, so what happened here in this? So when we hold this thin glass tube, on one end it was we were lighting it here in the candle itself, you can see, but the other end also caught fire, right? When we burned a matchstick, when we ignited a matchstick, the other end also caught fire. Why? Because this glass tube, it contained unburned wax vapors. Okay, it contained unburned wax vapors in it. Now these wax vapors, they entered the glass tube and they came out from the other end. So when we bring a lighted matchstick near the other end of the glass tube, the wax vapors coming out of started burning and started producing a flame. Okay. So from this activity we can see that a flame consists of unburned wax vapors. So what we can conclude that a flame consists of unburned wax vapors. Okay. So the unburned wax vapors, when we were burning here, it entered the glass tube and it started burning over here. Okay. Now let's proceed. The substances which vaporize during burning give flames. This I have already told you. An example will be kerosene oil, molten wax, rise through the wick and are vaporized during burning and form flames. Then charcoal on the other hand does not vaporize and so it does not produce a flame. Okay. In activity 4.5, could the vapors of wax coming out of the glass tube be the cause of the flame produced? Yes, exactly. Okay, exactly. This is absolutely right. Because the flames, they came out from the other end of the glass tube, the vapors actually, and then it caught a flame. Okay. See, now here this activity you will see. Where the candle flame is steady, in this one in figure 4.11, introduce a glass plate. Slide into the luminous zone of the flame. Okay, which is the luminous zone? The yellow one. Okay. Now hold it there with a pair of tongs for about 10 seconds. Then remove it. What will you observe? Now when you will bring this glass plate on the in the luminous zone, in the middle zone, you will observe a circular blackish ring. See here, a circular blackish ring. Right? It's formed on the glass plate or slide. It indicates a deposition of unburned carbon particles present in the luminous zone of the flame. Okay, because only partial combustion, partial fuel vapors only burn here partially. That is why they have unburned carbon particles present in this luminous zone of the flame, in this yellow zone of the flame. Okay. Now another activity, this figure 4.12, you can see. Hold a thin copper wire just inside the non-luminous zone. Non-luminous zone means this outermost zone. Okay, this outermost zone here. Hold a thin long copper wire, see here, inside the non-luminous zone. What is the non-luminous zone? This outermost zone over here, okay, of a flame for about 30 seconds. Now what you will observe is this portion of the copper wire just outside the flame, it gets red hot. Okay, because here in this outermost zone you will find the maximum heat. This is the hottest part of the candle. Okay, this is the hottest part of a flame. That is why when we place this copper wire on this in this zone, the copper wire got red hot. Now does this indicate that the non-luminous zone of the flame has a high temperature? Yes, in fact this part of the flame is the hottest part. Okay, now let's understand the diagram of this candle very clearly. See, just near the wick, if you will see just near the wick, this is the innermost zone of unburned wax vapors. Here the wax vapors are unburned. Okay, so as there is no sufficient supply of oxygen, so they are not burned completely. And this is the black zone, the dark zone. Then comes the middle zone. Here partial combustion takes place. Okay, again because the air supply is not that much, so because it's the second zone, so the partial combustion will take place and this will give you a yellow color flame. Okay, and this is moderately hot. The black one, the innermost one is least hot. Okay, then if you will talk about this outer zone of the candle, this is blue in color and this is the hottest part because it is receiving maximum air from the surroundings, right, as being on the top. Okay, that is why here the complete combustion takes place. The wax vapors, they get burned completely. Okay, now see, these goldsmiths, they blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver. Why do they use the outermost zone? Because they need very high temperature to melt this gold and silver. That is why they blow the outermost zone of a flame. Okay, because that is the hottest zone. Okay, so what is a fuel? Now we have already studied that what we can burn what we can easily, perform combustion with, those are fuels. So they are saying recall that the sources of heat energy for domestic and industrial purposes are mainly wood, charcoal, petrol, kerosene, etc. These substances are called fuels. Okay, and fuels are a very good source of heat energy as well. Okay, a good fuel is one which is readily available. Now, what are the characteristics of a good fuel? A good fuel is one which is readily available, means which is easily available. Then it should be cheap. It burns easily in air at a moderate rate. Then it produces a large amount of heat. It does not leave behind any undesirable substances. So these are the characteristics of a good fuel. If you want to choose a fuel, so you should keep all these factors in mind while choosing a fuel. Okay, for your home, for your industry, whatever you want. Then there is probably no fuel that could be considered as an ideal fuel, right? So there is no fuel as an ideal fuel. We should look for a fuel which fulfills most of the requirements for a particular use. Means at least three to four requirements out of these requirements. If the fuel is fulfilling, that is considered to be an ideal fuel. Okay. Now fuels differ in their cost. If we will compare kerosene with petrol, so kerosene is much more economical than petrol, right? It is expensive. Some fuels are cheaper than others, okay? Now make a list of fuels familiar to you. Group them as solid, liquid, and gaseous fuels in table 3. Now there are three kinds of fuels: solid fuels, liquid fuels, and gaseous fuels. One example they have already given you. So see, first example of solid fuel is coal. Then if you want, you can add here wood. Okay, wood is a solid fuel. Then you can also add coke. Okay, coke. Then liquid fuels, kerosene oil is already given. Then you can add petrol. Please bear with my handwriting. Then diesel. Then gaseous fuels, natural gas. Then biogas and coal gas. Please bear with the handwriting. Okay. So again, I am repeating if you're not able to understand what is written here. So solid fuels will include coal, wood, and coke. Liquid fuels will include kerosene oil, petrol, diesel. Then gaseous fuels will include natural gas, biogas, and coal gas. Okay. Now see, fuel efficiency. This is the next topic, fuel efficiency. Now, different fuels produce different amounts of heat on burning. Okay, all the fuels, they do not produce the same amount of heat. So suppose you are asked to boil a given quantity of water using cow dung, coal, and LPG as a fuel. Which fuel would you prefer, and give your reason? So uh, out of these three, LPG, cow dung, and coal, LPG will produce the maximum heat. Okay, out of these three. So I will choose LPG out of this because LPG will produce much more heat than burning the same amount of cow dung cakes and coal. Why? Because the calorific value of LPG is much higher than cow dung and coal. Okay, that is why I will use LPG as a fuel. Now give your reason. So reason is because of the calorific value. Okay. Then they are saying, do these three fuels produce the same amount of heat? No, definitely not. The amount of heat energy produced in complete combustion of 1 kg of a fuel is called its calorific value. Okay, so this is the definition of calorific value, and the calorific value of a fuel is expressed in a unit called kilojoules per kg. Okay, so this is the complete definition of calorific value, right? Now calorific values of some fuels are given here. So children, please learn this table as well. This is also very important. You can learn all these values. So if we talk about cow dung cake, 6,000 to 8,000 kilojoules per kg. So this means that the 1 kg of cow dung cake, okay, 1 kg of, if we'll burn 1 kg of cow dung cake is burned completely, then it will produce 6,000 to 8,000 kilojoules of heat energy. Okay, so we will be able to know all these, the amount of heat energy produced by all these fuels by these values. So wood, 17,000 to 22,000 kilojoules per kg. Then coal, 25,000 to 33,000 kilojoules per kg. Then petrol, kerosene and diesel will give 45,000 of kilojoules per kg heat energy. Then methane and CNG 50,000, LPG 55,000 kilojoules per kg. Then biogas 35,000 to 40,000 kilojoules per kg. And then hydrogen. This is the highest one, the most efficient fuel if we'll talk about. So 1,50,000 kilojoules per kg. Means, what do you mean by this? That by burning 1 kg of hydrogen, 1 kilogram of hydrogen is burned completely, then it will produce 1,50,000 kilojoules of heat energy. Okay. And also, if we'll go back to this candle diagram, I would like to add here. If you can add here in this middle zone. This middle zone is called the luminous zone as well. Okay, you can add this, and then the outermost zone is called the non-luminous zone. Okay, so just remember this as well. Now again, come back to our topic. Burning of fuels lead to harmful products. Now, burning of fuels is not always good. It has some disadvantages as well. Okay, so let's read this. The increasing fuel consumption has harmful effects on the environment. As the consumption is increasing, of fuels day by day, like petrol, diesel, wood. So what is this? What is happening is harmful effects on the environment. How? Let's see. Carbon fuels like wood, coal, petroleum release unburned carbon particles. These fine particles are dangerous pollutants causing respiratory diseases such as asthma. Okay, so burning of these wood, coal and petroleum, it releases harmful particles which are not good for our health, for our respiratory organs. So for centuries, wood was used as a fuel for domestic and industrial fuel. But now it has been replaced by coal and other fuels like LPG. In many rural parts of our country, people still use wood as a fuel because it's easy availability and low cost. However, burning of wood gives a lot of smoke, which is very harmful for human beings. So burning of wood also gives very harmful smoke. That is why it is bad. It has been replaced nowadays. It causes respiratory problems. Also, moreover, trees provide us with useful substances which are lost when wood is used as a fuel, because trees will be cut to use wood as a fuel. Moreover, cutting of trees also lead to deforestation, which is quite harmful to the environment. So that is why wood should be replaced. Okay. Then we will talk about second point. Incomplete combustion of these fuels gives carbon monoxide gas. Okay. Now it is a very poisonous gas and it is very dangerous to burn coal in a closed room. The carbon monoxide gas produced can kill person sleeping in that room. Okay. So Bhuja says, oh, so that is why we advise never to sleep in a room with burning or smoldering coal fire in it. Yes, because when coals burn in very insufficient supply of air in the room, right, because of closed door and windows, then a lot of carbon monoxide gas is produced, which is not good for our health. Okay. The third point, combustion of most fuels releases carbon dioxide in the environment. Yes, the burning of most of these fuels release carbon dioxide in the environment, which is not a good gas. We all know that. An increased concentration of carbon dioxide in the air is believed to cause global warming. Okay. And what is global warming? So global warming is the rise in temperature of the atmosphere of the earth. This results among other things in the melting of polar glaciers, which lead to a rise in the sea level, causing floods in the coastal areas. Low-lying coastal areas may even be permanently submerged under water because of global warming. So see, it is so dangerous. Then the fourth point. Burning of coal and diesel releases sulfur dioxide gas. It is an extremely suffocating and corrosive gas, a poisonous gas. Okay. Moreover, petrol engines give off gaseous oxides of nitrogen. Oxides of sulfur and nitrogen dissolve in rainwater and form acids. Such rain is called acid rain. So when oxides of sulfur and nitrogen they dissolve in rainwater, they form acids, and this causes acid rain, and this is not a good rain. It is very harmful for crops, buildings, and soil. Okay, if you remember the example of Taj Mahal, because of this acid rain, the effect of acids in this rain, the color of the marble is getting damaged, right? The use of diesel and petrol as fuels in automobiles is being replaced by CNG. CNG is compressed natural gas because CNG produces the harmful products in very small amounts, and moreover CNG is a cleaner fuel. So it is recommended to use CNG rather than petrol and diesel. Okay. So here we come to the end of this chapter. Let's read this, what you have learned. So the substances which burn in air are called combustible, right? Then oxygen in air is essential for combustion. This is an essential requirement for combustion. Then during the process of combustion, heat and light are given out. Ignition temperature is the lowest temperature at which a combustible substance catches fire. Inflammable substances have very low ignition temperature. Fire can be controlled by removing one or more requirements essential for producing fire. Water is commonly used to control fires, but water cannot be used to control fires involving electrical equipments or oils. There are various types of combustion such as rapid combustion, spontaneous combustion, explosion, etc. There are three zones of a flame: dark zone, the luminous zone, the middle zone, and the non-luminous zone, the outermost zone. An ideal fuel is cheap, readily available, readily combustible, and easy to transport. It has high calorific value. It does not produce gases or residues that pollute the environment. Fuels differ in their efficiency and cost. Fuel efficiency is expressed in terms of its calorific value, which is expressed in units of kilojoule per kg. Unburned carbon particles in the air are dangerous pollutants causing respiratory problems. Incomplete combustion of a fuel gives poisonous carbon monoxide gas. Increased percentage of carbon dioxide in the air has been linked to global warming. Oxide of sulfur and nitrogen produced by the burning of coal, diesel and petrol cause acid rain, which is harmful for the crops, buildings and soil. Okay. So here we come to the end of this chapter, and I will be posting this exercise in another video. Kindly go through it as well. And here we come to the end. Thank you.